My name is Carla Dove, and I am the Program Manager of the Feather Identification Lab here at the Natural History Museum, Smithsonian Institution in Washington, D.C. What we do here at the Feather Identification Lab and in this collection of one of the world's largest bird collections in the world is use this as a resource to help us identify the feather fragments that are retrieved for bird strikes. Species identification is the first step in bird strike prevention process. Immediately after this bird strike occurred and the evidence was collected in the field, it was hand carried to us. Because it's an important case, we wanted to use all of the tools that we have in our toolbox. We had whole feathers that we could bring out into this large research collection here and match up with museum specimens to make sure indeed it was a Canada goose. We have a DNA database that we helped establish for bird DNA sequences, so we could take the DNA from the tissues that we received, extract the DNA, compare that sequence to an online national database or DNA match, and we could look at the microscopic characters in the feather fragments that we received in these samples to confirm that it was indeed some kind of goose. The collections here at the Smithsonian Institution and the resources that we have available to us are unique in the world, and it's one of the reasons that we can do this kind of work. Once we confirmed the identification as Canada goose in this case, then we started to think about what else could we do? What more can we do? How can we push the science of this to figure out something else about these geese? The first thing that popped into our minds was we have feathers, and we can use these feathers to maybe figure out whether or not these geese were resident New York birds or whether they were from a migratory population.
After Carla Dove at the Feather Identification Lab in Natural History called me to ask me whether or not we could separate migratory versus resident Canada geese, I said sure. It's an interesting thing to do because residents outnumber migrants 4 to 1. And understanding whether or not they're resident versus migratory is actually really important for how we manage and ultimately reduce the risk of bird strikes in the future. Given that hydrogen isotopes can really tell us a lot about where these birds spent time because it's incorporated into their feathers and their tissues, what we decided to do at that point was to take feathers from known migratory birds, birds that had bred in the high Arctic, and known resident birds in the New York City area, in fact right near the LaGuardia airport. And we analyzed them all for stable isotopes. What we found was that the feathers from the US Airways flight that went down, those feathers matched the birds that were true migrants from the high Arctic and were not even close to the residents that we had sampled in the New York City region. We really don't think these birds were in the act of migrating north back up to their breeding areas. We think these birds were on a short distance jump looking for areas to forage, to get food. Understanding whether or not they're resident versus migratory is critical to how we manage around airports and make the airways safer to fly.